We present toward multi-granularity decision-making, explicit visual reasoning with hierarchical knowledge, a research by Yifeng Zhang, Shi Chen, and Qi Zhao from the University of Minnesota. A long-standing goal of artificial intelligence is to develop intelligent agents that can answer a variety of questions with relevant knowledge. The study of visual question answering has gained considerable attention in recent years. It centers around the ability to parse visual observations and correlate them with a variety of knowledge, and offers a practical platform for examining models' reasoning capability. While a series of progress have been made on improving the knowledge grounding and enriching knowledge pools for VQA models, they are struggling with the granularity of concepts and lack the capability of identifying relevant knowledge in diverse contexts. Let's take the following QA for example. To answer what is the color of the referred ground in the image, VQA models can leverage the learned knowledge from common samples. However, as they have difficulty in discriminating multi-granularity concepts, such as the more general term ground and one of its specific type grass, the dominant property green could be falsely linked to the dominant concept ground, despite the discrepancies between their granularity. The knowledge of mismatched property distracts decision-making and makes biased predictions. The mismatch between multi-granularity concepts can be handled with a hierarchical structure to associate each object with concepts of different granularity. Specifically, such a representation is critical for separating different knowledge facts to their designated granularity and unifying general concepts with specific ones for a context-rich and bias-resistant decision-making process. Aiming to enhance the model's reasoning capability among diverse sets of knowledge, in this paper we propose a hierarchical concept graph to incorporate the granularity of concepts, and a hierarchical concept neural module network to model the integration between observation and knowledge throughout the reasoning process. We first propose HCG to encode the multi-granularity knowledge. To enable a tight integration of context from observations and knowledge of different sources, we automatically generate our graph representation with a three-step paradigm. First, we perform concept extraction that determines the key relevant concepts from the observation. Next, we perform ontology formulation that separates relevant knowledge and their parent-child concepts across different granularity layers. And last, we conduct knowledge incorporation that properly attaches differentiating properties and relationships to multi-granularity concepts based on their level of details. With the proposed HCG, we further propose a hierarchical concept neural module network that explicitly integrates knowledge among diverse reasoning steps and justifies how it contributes to the reasoning. The essence of our model is to model the propagation of knowledge across different levels of granularity and reasoning steps. Therefore, we design a novel attention mechanism that operates on both the interlayer edges and the intralayer edges, and a neural module network to integrate the knowledge. Next, we present our quantitative results. First, incorporating the proposed knowledge representation leads to a considerable increase over its baseline on all datasets. Second, HCAM not only leads to improvements in answering accuracy, but also provides an interpretable interface to study how the knowledge contributes to the reasoning. Third, our proposed HCAM outperforms all compared methods on FVQA. The observation shows that our methods is able to distill the most pertinent information for visual reasoning. Ablation results show that both our knowledge representation and the reasoning models bring favorable improvement over the baseline across different reasoning datasets, emphasizing the importance of extracting and integrating multi-granularity knowledge with decision-making process. In qualitative analysis, we observe that our method is able to accurately identify knowledge closely relevant in the reasoning context and progressively accumulates multi-granularity knowledge across different layers. In summary, we present a principled method that takes advantage of the granularity of concepts. It advances with a novel representation that differentiates concepts based on their granularity and a hierarchical neural module network that progressively traverses the graph to reason with both general and fine-grained knowledge. We hope our study will be useful for the future development of knowledge-based visual reasoning methods. Our source code and data are publicly available. For more details, please refer to our paper for our project website.